We are going to use the potentiometer today in order to find a ratio between the EMF of two primary cells. The primary cells that we are going to select are Leclanche cell and Daniell cell. I have here a battery eliminator which is going to provide the potential difference across the potentiometer wire. I have a rheostat which is going to control the amount of current that passes through the potentiometer wire, and a key which is going to allow me to have the current in the wire or no. So, let us put this on. Check out the circuit. This is the positive connected to this terminal, and all the way from here the negative goes via this rheostat and the key back to the eliminator. When I switch this on, there is a certain potential difference across this wire. The positive being here, the current in the wire would flow like this. This is a 4 wire potentiometer. So, we are dealing with 400 centimeters of wire. The current goes this way and comes in the wire along here. If we are to recall the principle of potentiometer, if a steady current flows through a wire of any length, then the potential drop across a certain value of length remains the same, provided we have a homogeneous wire having same area of cross section, having same resistance per centimeter of the wire, and there is no change in temperature, or it could be a low temperature coefficient wire. So, let us see if that is happening in our case. Why we are doing this exercise is, this will determine how we are going to connect our primary cells for a comparison of EMF. Now, we will see the potential difference between these 2 points. The measure on each of these wires between the red and the black line is 50 centimeters. I switch on the current in my potentiometer wire, connect on the first wire at this point, and the other crocodile clip I place here. The length of the wire in between is 50 centimeters. Now, we will shift the crocodile clips to the next wire. The distance between the two would still remain 50, but let us see what happens. When we connect this crocodile clip on the second wire, the distance between the wire is still 50 centimeters. However, look at the deflection in the voltmeter, it is in the opposite direction. That is to say that the potential of this particular point is less than the potential on the other one, because it is connected opposite. However, if I keep the direction of current in mind in the potentiometer and connect on the second wire across the same distance as here, our value comes out to be the same as in the first case. This means any tapping for measurement of volts on this particular wire, volts meaning potential difference on this wire, must make sure that you are in the same direction as the potential drop. That means, the positive terminal here becomes very, very important. So, we have seen that it is necessary to keep in mind the higher potential and the lower potential on the wire. It has to be connected in a particular way, and study of potential drop is important. So, let us see how we can use all these ideas to compare the EMF of two cells that we have here, the Leclanche cell and the Daniell cell. We will require a galvanometer which will show whether the current is flowing in a particular circuit or not. So, let us disconnect this and make our connections using the Leclanche cell. From our previous knowledge, we know that this is the positive terminal of the Leclanché cell, and therefore, we must connect it to the positive in our circuit here. So, positive to the positive. So, the current flow would be the same if I were to use this negative zinc rod, place it inside this jar and complete my cell. I have the galvanometer and a jockey connected here. What am I going to look for? I am going to see on this wire a point where there is 0 deflection. What would that mean? That the potential difference created by this cell on the wire is exactly equal to that created by the cell, which would mean that there is no current flow in the circuit. That particular length of wire multiplied by the potential drop per unit length of the potentiometer wire, which we must know, let us say, and that value will give me the EMF of this cell. To start taking observations, let us find out what is the EMF of the Leclanché cell. Connecting the voltmeter across my Leclanché cell, let us see the reading. It is 1.4 volts. We are going to put the key in the main circuit. So, the current is now flowing. Remember, you need a null deflection. Therefore, you must check out whether the EMF provided by this cell is greater than the one that we are working with. That will ensure that on this length of wire, the potential drop at least one point is going to give me a value which is exactly equal to this. Because if you did not do that, if this EMF is less than this one, then nowhere on the wire are you going to get a null point. So, to start with, let us check on the first wire at any random selected point the deflection in the galvanometer and touch it. The deflection in the galvanometer is to my left, and when I take it to the last one, any random point, this deflection is to the right. That means there is a null point for 0 deflection anywhere on the wire. Go to the second wire, left, go to the next one, this time it is to the right, and we can then look for this value between the second and the third wire. Gently go all along on this wire, do not press the jockey too hard, bring the little slip so that you can use it to read accurately. Our 0 deflection in the galvanometer is coming at, on the third wire, as we said, 259 centimeters. For comparison, we will have to bring our second cell and repeat the same thing for it, which means for the Daniell cell, this is my positive terminal, and I connect that to the positive point on the potentiometer wire. The negative of this cell, which is my zinc rod, I place inside the porous spot and just connect it to the galvanometer. You can even use a two-way key, which allows you to have a permanent connection at a point for either one of them. A second key plug will allow you to connect it to the galvanometer, and by choice you can alternate between Leclanché and Daniell. The positive is connected to the voltmeter, positive, and we connect here the negative. Our reading is 0.7 volts. Let us now check out for the null point on this wire. We put the key in without changing anything else. because we have to compare. We are going to compare the lengths that we get, and that should be the ratio of our EMF. Checking the circuit out, left side, right side, second wire is already giving me another side deflection. Notice this is because this has a much lower EMF. So, I look for a position where I will get 0 deflection. I can read off on the scale by using these strips, placing them below and looking out for the reading. So, 117.5 is the reading with our Daniell cell. Switch off this current here. If you find the ratio of these two lengths, that will be the ratio of the EMF. One reading is never sufficient. So, there are two ways of taking multiple readings. One is that you change the value of potential difference across the potentiometer wire by changing the rheostat, or else you can put a resistance box and choose different values from the resistance box and take multiple readings. Formula: E1 is equal to K times L1 and E2 is also equal to K times L2, and remember K is my potential drop per unit length. So, its unit being volt per centimeter, the ratio therefore becomes just L1 and L2. You can also do another experiment with it, another way of calculating, and that is to plot a graph between L1 and L2. Let us see what that graph would look like. E1 from this formula into L2 is equal to E2 L1, and if I am making on my graph on the y axis L2 and on the x axis L1, this will give me an equation L2 is equal to E2 upon E1 into L1. Therefore, we will be expecting a straight line. This would be my slope of the line, and this is the ratio of the EMF of the two cells. So, as an extension to your exercise, you can plot a graph between L2 and L1. If you choose to plot between L1 and L2, then you will get the same result as this, that is E1 by E2, otherwise the reciprocal of the slope. One more suggestion you can try with the same apparatus working on the same principle is try out the EMF as reported by different cells and batteries which are available in the market. Say the dry cells that you use in the torches or for toys, check out their EMF by the same method, and that could be a nice project. We can use the potentiometer for other experiments as well. We are going to be able to use it for finding a location on the wire which will give us a required potential difference.